Good afternoon, everyone. Am I audible to all? Auditor, sir? Am I audible?
Yes, ma'am.
Okay, sir. So, good afternoon, everyone. Welcome you all in a day 2, third international conference on advanced computing and intelligence technology, ICACIT 2023. In this keynote session, we have Professor Danilo Pelesiu. Sir's keynote session on a topic on population-based algorithm and fuzzy technique for engineering applications. A brief introduction of the sir is as Professor receives his PhD degree in computational astrophysics from the University of Tremado, Italy. He is an associate professor at the Department of Communication Sciences, University of Tremado. Editor of books sir is the editor in books of Springer and elsewhere. Sir is the associate editor of IEEE Transactions on emerging topics on computational intelligence, IEEE Access, and International Journal of Machine Learning and Cybernetics. Sir is also a guest editor of Elsewhere, Springer, and Inder Sciences journals, and keynote speaker in several IEEE conferences. Sir belongs to the editor board member of many journals. His research interest includes fuzzy logic, neural network, information theory, machine learning, and evolutionary algorithms. Dr. Donaldo Pelesiu is an editor of Neuroscience Informatics. So welcome you, sir, in our today's international conference. Welcome you as a keynote session in ICACIT 2023.
Thanks a lot. Thanks for your invitation. And good morning here, good afternoon there, I think.
Yes, sir, it is a good afternoon.
Yeah, thanks. Yes, and now I share my presentation. It's impossible. I am not able to share the screen at this time.
At the bottom, here is in a green, you can see share screen option.
Yes,
yes, sir.
But it's possible because the other participants share his screen. I see this message from my PC.
Okay. Auditor, sir, please stop sharing at your end.
Yes.
Yeah.
Okay, it's okay now. Thanks a lot. It's not possible now. Okay.
Just
it's okay. Thanks. Can you see my presentation?
No, sir. It's not visible.
Now you.
Yes, sir. Now it is visible, sir.
Yes. Just a moment. Okay. Can I start now?
Yes, sir. Yes.
Okay. Thanks. My presentation will touch upon the optimization problems in particular problems where there is a huge complexity. And to solve this kind of problems is to possible use non-deterministic algorithms. Non-deterministic algorithms are algorithms with particular steps, and we consider for this task of to solve this problem, we can consider the population-based algorithms. Among these kind of algorithms, we consider the gravitational search algorithms, and in particular the regulation of a specific parameter of this algorithm to optimize some specific benchmark functions. Moreover, I will illustrate a novel optimization algorithm named the mode flame optimization algorithm. In particular, I propose an improvement of this kind of algorithm. First of all, we define the optimization problem where we consider x as x1, x2, xn, the design variables with x1, x2, xn that lies in an interval defined by lower bound and upper bound. And the aim is to find the optimal solution, in other terms, the minimum or the maximum of specific functions under constraint over a specific research space defined by lower bound and upper bound. For this kind of problems, in particular where the complexity is huge, the traditional mathematical programming strategies are not longer completely effective to solve this kind of problems. These problems are based on multimodality, discontinuity, noise, and these features make very, very difficult the optimization. So some problems can be solved by exact mathematical procedure, but we have to wait more time, and generally exact methods are too slow. Because these kind of problems have huge complexity. In other terms, we have to obtain the output of our algorithm in a reasonable time. So exhaustive methods are time-consuming, and the question is which algorithm is suitable to solve these kind of problems where the complexity is huge. There is a theorem named the no-free lunch theorem, which states that any two optimization algorithms are equivalent when their performance is averaged across all possible problems. In other terms, there is no algorithm able to solve all optimization problems. For example, an algorithm may be able to solve a specific problems, a specific optimization problems, but it is not suitable for other specific problems. So, in order to solve these kind of problems, we have to consider algorithms with low complexity. And so we can consider algorithms which contain some steps with ambiguity. For example, steps which have random initialization. For example, in the traveling salesman problem, an initial step is to establish the initial condition, the initial path. In this case, we can solve this problem by random initialization. Non-deterministic algorithms are algorithms which, with the same input, we can obtain different behavior on different runs. Generally, we consider a certain number of runs, and then we consider mean and standard deviation of these results. Unlike the deterministic algorithms, which produce just a single output for the same input, even different runs. In other terms, deterministic algorithms gives the same output with the same inputs on different runs. Now, non-deterministic polynomial problems are problems solved in a polynomial time. Polynomial time means that we obtain the output of our algorithm in a reasonable time through a non-deterministic algorithm. The non-deterministic algorithm is an algorithm which contains ambiguity steps. In order to overcome the issue of problem which have huge complexity, use complexity it's a problem also for the hardware which we have to consider. To solve these problems, we can apply soft computing technique. Soft computing is the use of approximate calculation to provide imprecise but usable solution to complex computational problems. Sometimes computational soft computing is referred as to computational intelligence, where computational intelligence is the theory, design, application, and development of biologically and linguistically motivated computational paradigms. Generally, we can consider three pillars of computational intelligence, such as neural networks, fuzzy systems, and evolutionary computation. Neural networks are systems which have the capability to learn from data. Fuzzy systems are systems where it's very important to consider the chronology inside these systems. And the evolutionary computation contains several population-based algorithms. Population-based algorithms named sometimes as swarm algorithms. This kind of algorithms are characterized by multiple individuals, and these individuals search the solutions among all the search space in a cooperatively manner and with different specific operators and mechanisms. In particular, we have the mutation phase, the crossover phase, the selection, and information sharing and learning. Mutation, crossover, selection are operators which contain randomness application, and in particular the generation of random numbers. So randomness is usually embedded into one or more operators, such as a crossover, mutation, and so on. And thanks this feature is the randomness of our steps. Thanks to these features, we have the capability to escape from optimal points and better explore the search space. It's more important in this kind of algorithms to consider the generation of random numbers. Well, among the population-based approach, we consider the swarm search-based algorithms, where these algorithms are based on a specific population, where at each generation, the current solutions are produced according to historical information obtained by previous generations. In other terms, it's very important to exploit the information which came from the previous generation and to exploit this information in the current generation. Among swarm algorithms, we consider the gravitational search algorithm. The gravitational search algorithm is a swarm intelligence algorithm, which is based on the Newton law of universal gravitation and the motion of individuals in nature. These formulas are the main formulas of GSA, where we can note that there is the gravitational interaction, direction force, and the second Newton law. Now we have to model these formulas, and we consider this model where we have the interaction force defined as shown in this slide, where xi, xj are position of height and j mass respectively. And it's very important to underline that the position of masses are the solution to optimize. In other terms, we have to find the minimum or the maximum of x under the search space defined by x1, x2, xd, where d is the dimension of search space. An important parameter of this approach is the gravitational constant. In GSA, the gravitational constant is defined in this way. It's very important to consider the parameter alpha. The parameter alpha is very important because, for example, if this parameter is low, then g of t is high. So the idea which I propose in this presentation is to apply a falsification on this important parameter. In other terms, we introduce a fuzzy tuning with the regulation of the parameter alpha, which is a specific and important parameter to assess and improve the optimization. And when we have to design a fuzzy inference system, we have to consider the fuzzy inputs and the output. In this case, the output is the parameter alpha, And the inputs are the number of iterations referred with n, or generation is the same, and the population progress. So the population progress is very important because it gives an information about the improvement of the population during the various generations. There is an improvement when the population progress is low. Well, another important choice during the design of a fuzzy inference system, another important choice is the choice of membership functions shape. In our case, we consider triangular trapezoidal shape, and we have three different membership functions for the inputs and population number and population progress. And for the output alpha, we have more than three membership functions, because it's very important to obtain a refined value of alpha to better improve and define the G of t, the constant parameter, the gravitational constant of GSA. The optimization problem on the optimization phase can be shared in two phases, exploration and exploitation. The fuzzy rules, which is another important design of our fuzzy inference system, the definition of these fuzzy rules depends on these two important phases: exploration and exploitation. Exploration is a early phase where the algorithm searches on the whole search space to find promising solutions and avoiding trapping. In other terms, exploration stands for global search. Vice versa, the exploitation is a phase characterized by fine search with the hope of improving the promising solution which came from exploration. In other terms, exploitation stands for fine search, and in particular local search. Based on these two phases, we can define the fuzzy rules. For example, when n is equal to low at the early stage of our optimization, the agents must have a big acceleration. Then we have to need of a low value of alpha, because if the value of alpha is very, very low, then G of t is very, very high. So the interaction force is very, very high, and so the acceleration is very, very high. In other terms, the agents have the capability to escape from local optima. At the end of iterations, there is an improvement in the optimal search. In other terms, when the population progress is low, then alpha has to be very, very high, because if alpha is very, very high, then G of t is very, very low. So the interaction force is very, very low. So the acceleration is very, very low. And we have at the end of iteration with the promising solution. This slide shows the rules table with inputs, fuzzy inputs and fuzzy output. This is the fuzzy surface. Now, if we apply our fuzzy improved GSA, if we apply this algorithm on benchmark functions, in particular on unimodal functions are benchmark functions very useful to assess the exploitation, because these functions have the feature to have just one local optima. In this way, we can assess the exploitation phase. As we can note that our approach reach before the minimum with respect to classical GSA. We apply our improved algorithms on multimodal functions. Multimodal functions are benchmark functions suitable to assess the exploration, because multimodal functions have more than one local optima, and so we have the capability to assess the exploration phase. This slide shows the improvement of our approach, and our approach is better than GSA because our approach reaches the minimum value of these functions in fewer iterations. Well, another approach, another population-based algorithm is the Mott flame optimization algorithm, which is an algorithm that exploits the navigation method of moths around the light sources. This algorithm is based on transverse orientations. In other terms, moths tend to maintain a fixed angle with respect to the moon. The trajectory defined by the moths is a spiral path. Into the population, the agents of MFO are the flames, where the flames are the candidate solutions, whereas the moth's position are the problem variables. In other terms, if we have to optimize f of x, the objective function, x are the positions. The aim is to find the optimal position. In other terms, the position which gives us the optimal value of benchmark functions. These are the main equations of Mott flame optimization model, where we can note that the spiral path is defined by MIK, which is the position of I Mott at k iteration, and d high k minus 1 is the distance between I Mott and I flame at k minus 1 iteration. Fi k minus 1 is the position of I flame at iteration k minus 1. And t is a random number. We can note that the generation of random numbers is very important. As said before, because this randomness it's very important to solve the problem of complexity of our optimization. Well, an improvement of these algorithms of MFO is proposed in these slides. In particular, the novel contributions are splitting the search process in 3 phases, because as I said before, we have exploration and exploitation. The idea is to introduce another hybrid phase between exploration and exploitation. Moreover, during each phase, exploration, hybrid, exploitation, a dynamic crossover mechanism to reproduce flames is designed. Moreover, in the central phase, in the hybrid phase, the phase which is between exploration and exploitation, we define fitness-dependent weight factor for mod position. In the later stage, so for the exploitation, we introduce a random elite flame set for updating the mod position. These are the main novel contribution to improve the algorithm mod flame optimization. Now, the dynamic crossover mechanism is based on a mechanism where the bed moths and the mutant flames are mixed through crossover for all phases. These strategies is applied on all the phases: exploration, hybrid, and exploitation. The mechanism in this kind of mechanism, the height mutant flame mixes the components with its best mod to obtain the crossover flame. This is the dynamic mechanism. It depends on current iteration K. Hence, with formula, we can note that we have the crossover flames. Note that we have R of J, a random number in 0, 1. And the crossover rate depends by iteration numbers, where big K is the max number of iterations. Vice versa, lowercase k represents the current iteration. If the crossover rate is higher, then more genetic information will be passed to the crossover flame from the mutant flame FM. Vice versa, if the crossover rate is lower, then more genetic information will be transmitted, conveyed to the crossover flame from the best mod H. The hybrid phase design is important because the idea is to avoid a sharp transition between exploration and exploitation phases. And the exploitation phase must be promoted without degrading the exploration capability. In the hybrid phase, we define a fitness-dependent weight factor, which depends on a ratio between the value of objective function over the best flame. In fact, f of m best is the effective function value of the best solution m best so far, and fmk high is the fitness function values of the height mod at iteration k. Well, we now consider the effects of the proposed strategy step by step. We consider the improvement by applying the dynamic crossover, by applying the hybrid phase, and by applying the fitness weight factor. We can note that there is an improvement of our approach with the introduction of novelty. Now, for the final search phase, in particular the exploitation, we consider the elite flames. In fact, a good way to improve the exploitation phase, the third phase, is to select the best flames among flames sorted in descending order according to their corresponding fitness. In other terms, we consider a certain number of best flames and repeat them into our approach. In this case, we consider a set of elite flames, which improve our research of optimal around the final generation. These are the results of our improvement with respect to the mod flame optimization algorithm. We can note that high MFO reaches the best value before with respect to the other approach. And before, because we have fewer iteration number, and the minimum values is the best with respect to the other comparison algorithms. So with this is the application of our improvement mod flame optimization algorithm, in particular for a multimodal benchmark function. In this case, we can note that our approach, our algorithms improve the other competitor algorithms, because even the minimum is the same, our algorithms reach the minimum with the fewer iteration numbers, so fewer generation. The high MFO can be applied to optimization engineering problems as well. For example, the welded beams design problem consists of minimizing the fabrication cost of a welded beam. For example, we have 4 variables to optimize and 7 constraint functions. This is the results of welded beam problem. We can note that we have the better optimal cost, the minimum cost, which respect, for example, MFO, GSA, and so on. Another engineering problem is the gear train design problem, which is based on the minimization of the gear ratio for a given set of 4 gears of a train. We have 4 variables to optimize. We have not constraint functions, and we have the better results, which respect, for example, MFO and others competitor and population-based algorithms. Another application is on pressure vessel design problem, where the objective is to obtain a design for a pressure vessel with the least fabrication cost. It has 4 parameters and 4 constraints. In this case, we have this optimization. Also, even in this case, we cannot that we have the best results. Another application is on cantilever beam design problem, where the cantilever beam consists of 5 hollow blocks. In fact, we have 5 variables to optimize. The design problem is to minimize the function f of x with just one constraint functions function defined referred with g of x. These are the results. In this case, we have again the best results. And another aspect very important to consider is the computational complexity analysis. For example, we have best results with respect to classical MFO, but it's very important to underline that the computational complexity of the improved algorithm is the same of the classical algorithm. In this case, it's very important to consider that the computational analysis is very important because several researchers consider CPU times in second is not completely correct because the CPU time depends on hardware performances, programming languages, skill of programmer, and so on. If vice versa, if we consider the big O notation, the mathematical notation named big O notation, we have a good evaluation of computational complexity. In conclusion, we have introduced how to improve GSA with fuzzy regulation parameters, an hybrid search phase for mode flame optimization. And it's very important to consider that we have achieved best results with the same computational costs. These are some reference of these results, and thanks for your attention.
Thank you, sir. Any questions from anyone's side, please? Participant, anyone wants to ask any questions? Okay, I think, sir, no one questions from the participant side. So thank you so much, sir, for your wonderful keynote session. We are grateful for the time and effort you shared with us. I believe that, sir, your experience and depth of knowledge in the topic of population-based algorithm and fuzzy technique for engineering applications will be benefited to our today's conference authors and participants. I personally appreciate your valuable insight for this track. We look forward to you for your participation in our future events. Thank you again, sir, for your contribution in International Conference on Advanced Communication and Intelligence System, ICACIT 2023, sponsored by CCIS. Thank you, sir.
Thanks a lot to you, and good work.
Thank you, sir. So the now move to the second keynote session. For the second keynote session, we have Professor Dibhas Dey. Professor is a senior member IEEE, fellow IETE, and life member of CSI. Professor was awarded with the prestigious Boyce Cast Fellowship by the Department of Science and Technology India to work at the Heroic Watt University, Scotland, UK. He received the Endeavour Fellowship Award from DEST Australia to work at the University of Western Australia and received the Youngest Scientist twice in New Delhi and in Islamabad, Turkey from the International Union of Radio Sciences, Belgium. He established the Center of Mobile Cloud Computing, CMCC, for IoT applications and is vice chair and sir is a vice chair of Due Computing STC of IEEE Computer Society. Dr. Day has published almost 320 journals and 200 conference papers, 15 books, and filed 10 patents. His research interests are in edge AI, IoT, and quantum computing. So welcome you, sir, for your keynote session on the topic of Internet of Drone Things. Day, sir, please share your presentation. Participant, please wait for 2 minutes. Participant sir is joining shortly due to some technical problem. He is not able to join. He is trying actually. So please stay connected. Sir is joining shortly. Good afternoon, sir.
Good afternoon.
So shall we start the keynote session?
Yeah, Moha madam is there. Moha Nandipal.
Yes, sir, I'm present.
Yeah, can you please share the screen? Yes.
Okay, I'm sharing.
Sir,
Yes.
I'm just briefing your introduction.
Sure.
Yeah. So good afternoon, sir. Welcome you, sir, in today's conference. As a brief introduction of Day, sir. Sir is a senior member in IEEE, fellow IETE, and a life member of CSI. Sir was awarded the prestigious Boys Cast Fellowship by the Department of Science and Technology, India, to work at the University Scotland, UK. He received the Endeavour Fellowship Award from DEST Australia to work at the University of Western Australia and received the Younger Scientist Award twice in Delhi and in Istanbul, Turkey from the International Union of Radio Sciences, Belgium. He established the Center of Mobile Cloud Computing for the IoT applications, and he is a vice chair of Due Computing STC of IEEE Computer Society. Dr. Day has published 320 journals and 200 conference papers, 15 books, and filed 10 patents. His research interest in the area of Edge AI, IoT, and quantum computing. So welcome you, sir, in our today's keynote session.
Yeah, thank you, madam, for your kind introduction.
Welcome, sir. Sir, please
and-
you share your presentation.
Yes. Moha madam is presenting. Yes.
It is visible, ma'am, now.
Yes.
Okay.
Thank you very much. And let's start with this. Today, I'm just going to discuss on the topic of Internet of Drone Things. And this is a very interesting area where we are connecting multiple drones together through IoT platform. And
Participant, Mr. Sahil, please mute your mic.
see, when you're talking about IoT, Internet of Things, which is the key player for connecting the whole world through various IoT protocols and rules and regulations, obviously through the help of the internet. So here is the extra term D comes, D for drones. We call it IoDT. Instead of IoT, we are calling it IoDT. It's a type of IoT system where we are connecting the multiple drones for the smart city development. Now the question is, the privacy is a very important factor for modern security system. So we have used federated learning technique to provide this privacy in our system. So for next 45 minutes, I'm just going to discuss about how this federated learning is used to develop the privacy preserving Internet of Drone Things. Next slide.
Sir, please wait.
Now these drones are very important key player for the modern surveillance, for say from agriculture to if you go to the system of the surveillance in the cities, in the border area, drones are playing a major role. So we have developed the models with the help of the project of ISEA, the Government of India project, where we have talked about privacy and security threats for human resource development using this cybersecurity domain. Next slide. So ISEA project is giving the support for this. So this is the outline of my talk. Part A will be discussing on the Internet of Drone Things. Second part we will be discussing on drone security, and third we will be discussing on federated learning based Internet of Drones. Next. Next. Now we have a center of mobile cloud computing, and through this center actually we are developing the mobility models, various mobility models of drones. And if you see this picture right hand side, this is a book called Mobile Cloud Computing, where actually the mobile to data is going to the cloud through various applications, apps. And these apps are actually controlling the whole world. You know that nowadays our mobile phones have various kinds of apps. We are getting the service. So here we are getting the service in terms of mobility. So if you see the drones, the drone is here available for providing this edge level service providing for the smart city development. So there are various kinds of services for security, privacy, and other things. So we develop the models of Internet of Drone Things based on the basic computing capability of mobile. That means we are connecting your drone. Drone is also a mobile device. We are connecting this mobile device to the cloud using these apps, right? Next slide, please. And these are the very basic mechanism. And as everyone know that drones works with 4 wings generally. It has a BLDC motors, and this BLDC motor is also available in our fan. You know, this nowadays we are all using these BLDC motors with very high speed rotation. And in our house also we use this BLDC motor fans. Next. And the fans, the motors giving the thrust to the ground. And during the takeoff, we are giving equal and opposite direction. And the drones are moving up on the sky. Based on the thrust level we are giving, providing the height of the drones, the height the drone will reach will be based on the thrust provided by the wings. Next, please. Now, if you see this very basic principle of physics, that your lift must be greater than the weight. Then only the drone will move up, right? So lifting force must be greater than the weight. So weight is a very important factor. So now we are designing these drones with lightweight materials. If the drone weight is equals to the lift weight, then you can see it will hover on the sky, right? Hover means it will be moving on the sky. It will move around the system on the sky, right? So this process is known as hovering. Next. Hovering means it will stand still. And the drones, you know that all the drones are moving in the clockwise and anti-clockwise motion. 2 sides is clockwise, other 2 sides are in anti-clockwise mode. So clockwise and anti-clockwise mode, these drones are actually operating. Next. Even nowadays, you know, you will see that drones are also available for carrying the human being. Even I got the opportunity to sit on such drone. And this drone is actually used in Indian military system, especially for Navy, for transferring the people from one place to other place. Especially during the disaster management time, these drones are playing a major role for our rescue operation, everything. So maybe in future, you will see lots of drones are moving on the sky as alternative transport system and all over the world. Okay, next. Now, if you see the basic scenario of cloud, fog, edge computing domain, on the top we have cloud, after that we have fog, and at the end we have edge. And these edge devices are like mobile devices, laptops, tablets, and we also have intermediate fog devices, which is in between the cloud and edges. If you want to send the data to the cloud, it takes a lot of time. So we need the real-time operation, right? To connect the multiple drones together. So we are using edge computing. And we are providing this intelligence or whatever we want to give it to the edges. So we call it edge AI or intelligent edge, right? So we are providing this very high-end security to the edges of the devices. So our current day AI is now operating at the edge. So the system can be operated in a real-time fashion. Next. If you see the smart city, starting from traffic signal lights control, if the drones are there. They can manage when the turn will this light will turn green or red or yellow. So it depends on the number of traffic. Drones can take very much intelligent decision making, and multiple countries they're using this drone-based traffic control systems. Also the accident management systems, or for traffic fine. If you are doing overspeeding, drones will go and catch, take your picture with your number plate of the car, and they will accordingly they will provide this to the fine for the person who is doing overspeeding. Second case, in the middle, we can see this drones are also used for smart home applications, especially for giving the healthcare for the senior citizens. Drones are acting as a agent for hospitals. They come on behalf of the doctors. They can take your images. You can talk to the doctors using this drone camera, and they can scan some, if required some part, they can do medical operations. Even it can do the medicine delivery, like the food delivery system, which is already in place. Also the power grid. So we have multiple operations of these internet drones. And most important, all the drones are connected to each other. They're all connected to each other. They're combining everyone's power or strength, and accordingly they're providing the solutions. And that is the beauty of Internet of Drones. Next, please. Now the question is, where these drones are learning? They're learning in the air. It's very important. When the drones are flying on the sky, the training, the machine learning means the training is happening on the sky. The drones are learning in the air. It's very important. So this is one of the very interesting but challenging at the same time, because during this mobility we are learning, and what they're learning, how to keep the space different, how to connect, what not to do and what to do. These are the various important factors. We are giving this training factor to the drones so that we can have a collision-less intelligent drone network. So we are calling intelligent drones, and where they are learning in the air. Okay, next. So we call it mobile edge intelligence, right? So edge intelligence is there, that we are providing this intelligence at the edge, but this is mobile edge intelligence, which is the confluence of mobile edge computing and artificial intelligence, right? Next, please. Next. So we have written 2 books on this similar domain. One is called Mobile Edge Computing with Professor Rajkumar Bhuiya, and second one is all AI for IoT. So if you see these 2 books, then we have given what are the algorithms are there, what are the that learning mechanisms are there for the drones, especially in the mobility. It can be drone, it can be any mobile devices, or it can be vehicular network. How to provide this intelligence in the edges, and especially how to provide the intelligence at the edge, right? Next. Now, if you see the level of intelligence, generally in the intelligent network, we are classified into 3 levels. Lower level is known as terminal intelligence. We are providing this intelligent tiny devices for the vehicular network, say driverless car, also for drone network, also in other applications where the intelligence is provided at the edge level. We call it terminal intelligence. In middle layer, we are sometimes process the data in the towers, mobile towers. We call it local intelligence. But if the data size is very high, then you have to go for core network. We call it centralized intelligence. Yes, centralized intelligence is good, but more robust, but it takes a lot of time to operate. This is not real time. But if you want to go for real time and less latency, then you have to go for terminal intelligence. So we have to go for the last stage. That means the drone level. Terminal intelligence provides lower latency and also very much real time. So need of the hour is real time, because we want driverless cars, we want autonomous drones. So this is the future. Next, please. You know, the 5G and 6G networks are coming up with very high speed data. So that is helping for very high rate data transfer, and that is extremely helpful for ultra high speed data transfer. Thank you. Next slide. You know, you can see the birds can fly of their own, right? No one gave instruction. If a bird can see a fruit or any event, it can fly of their own. Similarly, we are also developing the drones, which is autonomous in nature. When you can see, drones are installed in a certain places on the road. If they can see certain accident, for example, in this picture, we can see 2 persons lying on the floor due to the accident. Drone will capture the image using this deep learning technology from the control room. They will send the ambulance or this kind of thing. So it is autonomous in nature, right? Also, if there is some kind of fire, if some of the car catches fire, it will send the ambulance as well as it will send the fire brigade to stop the fire. And that is a basic working principle of autonomous drones. So that means drones, they can take their own decision based on the intelligence provided in the drones, right? Next. Now, these are certain applications: infrastructure, agriculture, transportation, security, entertainment. You can see lots of movies are done using these drones, especially for high sky photography, insurance, telecommunication, also in mining. Underwater drones are very popular nowadays. Next. So this is a picture of agricultural drones, and on the big paddy field, this multiple drones, they're connected to each other. They can coordinate to each other, and they can get the information from the various corners of the paddy field, how this actually things are happening. And instead of putting the pesticide in the whole field, they are putting the pesticides only in the affected zone only. By that process, they are saving the money, and it's good for the business point of view, also from healthy growth point of view. So multiple drones are operating together to give very good agricultural output. Next. So if you see, these drones are so powerful and it can handle large amount of data. Please click, data will come here. So it can have volume, velocity, and variety. Volume means large amount of data it can carry. Velocity means high speed it can move, and variety of data, heterogeneous data it can handle. Next. So three V's: volume, velocity, and variety it can handle with their own intelligence, right? So we can see that if we combine the IoT with this drone, means Internet of Drones, it is equivalent to an elephant is flying, right? Isn't it? Because you can see that elephant means huge data. It indicates the large data or big data. Volume of data it can carry, and it is only possible because of the solid state devices and the nanotechnology. Drones can carry huge amount of data by itself, right? When the IoT is combined, it can capture the data for say 24 hours for longer time, and by this process, drones are sufficient enough and intelligent enough to take their own decision like this. Next. So by this process, we can tell you that drones are like a Superman, right? If you see the previous slide. Previous slide, please. Yeah, drones are like a Superman. Superman means it indicates that it is the power, the strength, and the intelligence of Superman has. So we are providing that much amount of intelligence to the drones, which can take their own decision. It is powerful, it is robust, it is real time, and is also doing very high speed operations. Next. Not only we are interested in the this on the sky drone, we are also interested in combining this on the land, on the sky, also the underwater. So we call it AUV network. AUV means acoustic, it is underwater. So we have to cover the underwater system as well. If you want to cover the whole world connectivity in terms of IoT, IoT or Internet of Everything is combining everything in the world. So 70% is water, right? In that. Next slide. So we have to cover the full system, AUV, UAV network. So PwC is one of the company. They have given a very interesting tech forecast that what will be the properties of Internet of Drones. In 2016, they said, that time it was futuristic, but nowadays everything has been implemented so far. These drones can fly, they can crawl, they can talk to each other, means they can communicate through IoT, right? They can recognize the faces and objects. They can also climb, they can also grab the products. Okay. So the last point was very important. They can give each other space. Means while they're moving on the sky, they should not never collide. Otherwise, it will be accident, right? So there is a collision avoidance technique or is used for the drones to avoid this collision, right? So this is very important that when you are talking about this drone-based system, this collision avoidance is very, very, very important factor, right? Next. So these are the snapshots of our laboratory where we develop these drones. Yes. Next. Next. So these are the properties that drones support: edge layer, fog layer, all these things for uploading the data for data balancing purpose. Next. Yes, drones can do a lot of data collection. They can fly in a very high altitude, also a low altitude. There are various types of drones are available. Even you can see in the war in various, which is happening is drone based, unfortunately, but this is happening here. Next. If you see the evolution of drones, it started in 1950, but drones have become so popular in recent years because they become autonomous. If you see the history-wise, is 1950 it started. Next. And this is a basic anatomy of drone in our lab. Next. These are the autopilot electronics part of the drones. Yes. You can program it. You can also have the radio modules for connecting to the 433 megahertz connections. Next. Now this is some futuristic technology that we need drone-based 5G, 6G network, also flying base stations. You know, when the drones are flying on the sky, they need power base stations, right? For charging base station, like our EVs, electronic vehicles. So flying base stations are coming up with where the drones can take rest and they can charge themselves with a wireless charging system, right? Next. These are the part of some futuristic technology. So if you see the drone architecture, middle there is a edge layer, next is a fog layer, then over the top we have cloud layer. We have multiple applications in smart cities, which is shown in here, in smart grid, to traffic light control systems, to healthcare. Every sector actually IoT works. Next. And this shows the multiple layers one by one. First layer is a perception layer or sensing layer, then edge, then gateway or fog layer, then the cloud layer. Next. So these are the multiple layers of how this drones operates. Now, if you see the challenges, next. There are multiple challenges. Those who are especially doing research in the domain of Internet of Drone things, these are the food for the thought for them. Most important part is the routing challenge, mobility model, because you know that various mobility models exist. Power management is very important issue because drones are flying on the sky, they need the power. But most important thing is the intelligent processing and decision making. Drones must be intelligent enough for taking the decisions on the sky. Last part is privacy and security. You know, this is a very important privacy and security. Today I will discuss on privacy part, right? Next. This is one of our paper where we have published using the drone, using this MQTT protocol. MQTT means message queuing telemetric transport protocol, where we have used this opportunistic Internet of Things, drone things for using this mobile edge computing. Next. So these are the ecosystem, how multiple drones are connecting to each other with their various edge devices, with edge layer to cloud layer is given here. I'm not going in details of it, but we have shown various protocols which is used in different layers. Next. Yeah, there are various protocols like MQTT and MQTT-SN. SN stands for sensor network. MQTT-SN is another network protocol which sometimes that communicate with MQTT, because these drones are sometimes heterogeneous. So multiple protocols they are using, but they must talk to each other to communicate to each other to have a better network services. Next. So these are the prototype, how these prototypes are developed with various programming tools are there shown in this picture. And how we have used this cloud called IBM Cloud we have used for data processing part. Also, the left side is a edge layer and right side is a cloud layer. So we have deployed practically these drones for the connectivities and data exchange purpose. Next. Next. Now, very important thing is that we have various levels of connectivity. QS0, QS1, and QS2. QS means quality of service. You know that like our hotels, we go for hotel booking, room booking, we are asking for better service, we have to pay for, say, QS2. But if you want to stay in a basic room where you can simply stay and take bath, then QS0. So if you want to pay more, you have to go for QS2. The complexity and the features are very high for quality of service, QS1, 0 to QS2. Next. I'll show you how this QS0 works here. MQTT is a broker where publisher to subscriber. Publisher is one drone, subscriber is another drone. Okay. Publisher is one drone, subscriber is another drone. This we call it pop-sub model. One drone can communicate to other drone using the broker called MQTT broker. And in between you can see the connect or publish modules are there, which shows the connectivity from one network to other network, how the system works, right? If you go for next QS1, this is QS0. If you can see the next slide, it will be QS1. Next slide, please. Yeah. So you see the connectivities are more. QS1, please. Yes, QS1 connectivities are more compared to QS0. More amount of acknowledgement, publishing acknowledgements are there. This is providing better service compared to QS0. If you go to QS2, quality of service 2, level 2, next, you can see multiple more connections are there. So actually, this will increase the quality of service and the reliability of the network, right? So how this one drone will connect to other drones with this IoT platforms, and this is shown in this pub-sub model using MQTT broker. This broker is used to connect one drone to other drones, right? Next, please. Now, these are all opportunistic message transfer. Next. So this is the mathematics I'm skipping. Next. Now, this slide is very important, that Internet of drones means one drone is connecting to multiple drones, or vice versa. We know that it can be connected in number of drones. So one drone, suppose there is a publisher drone, you want to connect here in this picture, I can show you 3 drones are connected. It can be 10, it can be 100, it can be 1,000. It is written 1, 2, and n. N can be 1,000 also. N can be 10,000 also. So one drone can communicate to it multiple number of drones, right? It can connect with multiple number of drones using this IoT platform, right? So one-to-many connectivity is possible. So this indicates a property called scalability. It's just like that in our classroom, we have 10 students or 100 students, or, if you have a bigger auditorium like conference, we can have maybe 400 or 2000 students, right? Or participants. So this is the most important part, the scalability of IoT, right? That is the beauty, that is the power of Internet of Things. We can connect n number of products, n number of devices using the protocols. But there is some challenge. Challenge is the heterogeneity. If you have various kinds of protocol, we need to use this technology called interoperability, which is a very important aspect of IoT. Through the interoperability, we can transport one protocol to other protocol. So this interoperability is obviously a challenging one, because every company has their own products and the risk is involved. When you are talking about interoperability, the handshaking must be done properly, otherwise drone cannot communicate. So this is the important challenge as well as very important aspect of connecting multiple drones together to form this IoT network. Next. So this is the same thing, that how these drones are connecting, and this is the details of how this MQTT operation is going on, one drone to other drones, and details, acknowledgement, and the protocols are shown in this picture. Next. 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 So you can see the various results, bandwidth, results with next. I'm not going in detail. So these are all the time requirement for connecting. Next. Next. And transfer times, operation time. No, these are all the various energy consumptions. We have calculated and we measured it practical when the drones are connecting to each other, because power level is very important to remain connected in the network. So this is very important, that how these edges will be operating. And next. This is the comparison of various drones with energy consumption. Next. This is one of the paper we have published with Edge Grid. Next. And Springer we have published. So it is paper shows that if there is any failure in the grid, power grid, sometimes high-end the drones are used next to connect one of the failure session, and it can provide power temporarily. Drones can even temporarily transfer the power to the power grids. Yes, next. These are the snapshots. One of my students, Samarth Mukherjee, is working in a lab. Next. So not only we have worked on the sky drone, on the air drones, we also worked on the underground drones. Next. Because this is one of the picture of underground drones. We have one of the drone with us, and which operates in the underwater domain. Next. It has camera and it has also field of views. So through the app, I have mentioned in the earlier that through the app we can control the drones on the sky. We can control the drones under the water. This is the beauty of connecting. By this way, using the app, we can connect the whole world on the sky, on the land, as well as under the water. So this is the total ecosystem of connecting the three layers, Swargo, Matto, and Patal, means on the sky, on the land, as well as under the water. Next. So we have modeled some of the things. We have developed some software-defined network or software-defined model for IoT, Internet of Things, for edge layers. We have published in one of the Elsevier journal. Those who are interested, they can go through it in detail. Next. Yeah, drones are all, obviously, I've mentioned that it can handle the big data, volume, variety, and velocity it can handle. Next. Now we are coming to the security domain. Next. The drones are also used with anti-drone. That other countries are using this anti-drone to stop the drones coming to the territory. Next. Another very important technology is called blockchain technology. Blockchain operates with hash function. If one drone has a hash, if we can give the hash to the second drone, then only the drones will be authenticated. If the hash does not match, then the other drone is an intruder. We can simply make it as an outlier. Means we will not allow them to come and join your network, right? This is the actually beauty of using this blockchain-based Internet of Things. We have published one book on this, how this drone chain, we call it drone chain. So all the drones are connected with as a chain, like blockchain. But if someone is intruder whose hash is not matching, then he's not the part of network. Maybe it is an intruder by the other country. They send it to your group. So we must destroy them, or we must protect them. We should not exchange any data with them, right? And using this edge computing in real-time fashion, we have to understand whether it is your own drone or intruder drone, right? So drone chain is going to be a very popular, although it is in research stage, not yet be implemented properly practically, but research is going on extensively to provide lightweight blockchain technology for IoT, right? Next. Now, these are some of the federated learning technologies I will be discussing now. Next. And there are some nature-inspired algorithms are there to which is used for collision avoidance of the drones. Collision avoidance means when drones are flying, they should not collide. Like that glowworm, Jonakipoka. The glowworm, which is actually used. Next slide, please. Is that the glowworms are moving in the dark, the areas where they fly, but they never collide. We have used the same working principle in our drone theory, and we got very good result out of it. The use of GSO in our IoT platform. Next. Next. So these are the some models we have developed. Next. How these drones will move without any collision. Next. Now these are the movement of the drones on certain area. Next. This is actually, we try to find out that there should not be idle area, so coverage is maximum. At the same time, there is no collision. Next. So you can see some of the papers are available called Flying Ad Hoc Network using GSO, Global Swarm Optimization. Next. Which figure shows that when the drones are moving using the working principle of this glowworm, they will never collide. That is a requirement of clustering. Yeah. Next. Next. So they actually work in this working principle of GSO using proper cluster so that the drones will never collide to each other. Next. Next. This is actually a flowchart. We also worked on some of the domains called movement score based mobility management. Means, we have to find out the movement score. That one drone should not fly from a long distance. So the mobility must be limited. So we have developed a new method. We call it movement score based limited grid mobility. That means you have to be within your territory. If you're in your state, in your country, you shouldn't move out of it. So you should be within confined to your own zone or area. So we got very good result for collision avoidance. Otherwise, if your movement score is not limited, the possibility of collision is high. So we have published this paper for collision avoidance. We published in Ad Hoc Network. Next. Another work we did using the fuzzy logic for movement score. We published in Computer Communication Journal that how this fuzzy logic based movement is going on for GSO based things for mobile wireless network or even for drone network, it will be operating. So fuzzy logic play an important role for the movement score based management of drone mobility. Ultimate goal is that there should not be any collision when the drones are moving. All this working principle. Yes, next. Next. So these are the challenges, right? What is the speed? What is the direction? What is the angle or pattern? Is the movement essential? No, it's not essential. Drones can be sometimes stationary. Movement is not essential. How to improve the efficiency? Nowadays we are using the technique called energy harvesting to stop this energy loss. That means when the drones are moving, it can also generate energy. Your movement, then is mechanical movement, can be converted to electrical energy. So we can also harvest energy by this process. Next. And there are lots of applications of drones in the COVID-19. So for the protection from the COVID to the citizens, also for delivery of vaccine, drones play a major role for last 3-4 years during the time of COVID. You can see all the examples are given. And there is a huge amount of application. And that time, actually, the drone becomes more autonomous and intelligent. And by this process, actually, we are getting excellent kind of result, okay, when the drones are operating in the unmanned zone areas, especially in the remote areas, they're providing excellent solutions. Next. Now we can see when the drones are operating in the sky, especially, the Delhi and NCR, those areas, the pollution is extremely high. Even yesterday I was also in Delhi, huge amount of AQI, air quality index is there. So the pollution is extremely high that time, unbelievable pollution. Yeah, even I was wearing mask yesterday, right? But people are using Diwali or various other festivals. They are using firecrackers. They're causing lots of pollutions. So we can think of this pollution-free intelligent drone lighting system for our citizens, so that we can avoid this kind of the chaos, we can say, pollutions. So we can definitely design various kinds of patterns with hundreds, thousands of drones, which can design the pattern. Everyone can enjoy the lighting systems without any pollution. Next. This is actually the drones are lying on the floor. It is actually programmed with 3D models. And nowadays, if you can see the Olympics and various games, these drone lighting systems are very popular, using this Internet to drone things, where we can see the multiple, the drones are actually operating together to make this beautiful lighting systems, right? But there is another problem. If your enemy is there, if they want to come, say, suppose you made a flag of a certain country, your enemy, if they can hack your software, they can change the pattern, right? They can change the pattern to other countries, their pattern. So they can do this intrusion. So a lot of risk is there. So even it happens, there are a lot of incidents that has been reported. If someone can hack your software, you can have different kind of patterns on the sky. So that is the biggest challenge in this area of drone lighting system. But people are working on the security aspect, also the machine learning based drone lighting systems. Next. Next. We also worked for drone systems for social Internet of Drone Things for 6G network. We already published in this work. So 6G, what is the purpose? To make it much more robust, faster network. Next. We also have done some work called healthcare domain, real-time stride analysis. Stride means how the people are moving. Okay. We published in Computer and Electrical Engineering Journal, where the drones are actually moving on the, that real-time stride analysis, and that based on the movement of the human being, using this drone scanning, we can understand what kind of disease they have. Next slide. So drones are used for disease detection. Say, suppose in a hospital, using this drone, if we can see how these people are moving. What is the stride? Stride means how they're walking. From there, we can detect, the drones can detect what kind of disease they have. Disease they means the patients have. So especially the neurological disease can be easily detected, right? Next. So using this foot analysis or data coming from your shoe, right? We need some experiment with the image processing, putting the IoT shoes, okay? And using your this high-end high-speed network, we detected the disease, that healthcare domain. So drones are also used for various kinds of health analysis. Drones can move around you in a circular fashion just by controlling their drone's wings, and they can detect, they can take your real-time picture, how you walk, how you move, how you behave. So that can be detected and health analysis can be done. Okay. So if you're interested, you can go through this paper. You'll get in details. Next. This is very important that we are all talking about since morning, that for last 45 minutes we have discussed about drones, but internet of drones without internet is not possible, right? Agreed? Ankush sir, are you there?
Yes.
Yeah, so problem is internet is the biggest challenge, right? Internet. Many places in the world, there's no internet. So what is the solution? We have published one solution called Dude Drone. It published in IEEE Consumer Electronics magazine. What is that? That if there is no internet connection for a certain amount of time, drone can hold the data in the cache memory. Cache memory even it is in our mobile phone, right? If the cache memory is high, it can hold the data for a certain time, as if there is no connectivity lost. So we call it cache computing or dew computing. Okay. We published this paper in IEEE. Those who are interested, they can go through it. We developed a model. Even the drones can be operated in certain area where the internet connection is unstable. So we have to give more cache memory to the drones to tackle the situation for uninterrupted connections, right? So this is a very important challenge. Next. And I've showed you this is the cache memory. The devices are coming up, Intel and various other companies are coming up with high-end cache memory. Even if you see modern days camera, even your microwave, your washing machine, they comes with high cache memory. If you buy a high-end mobile phone, that also has very high-end cache. That means the data connectivity cannot be lost, right? For example, we are now on Zoom platform, right? If someone's mobile phone data is lost for a certain amount of time, say 20 seconds, he'll be out of the network. But if your mobile phone has higher cache memory, even if the network is unstable, you'll be always connected. The people has tested it using this dew computing domain. And that is the reason we are giving more cache to the drones for uninterrupted connections. Especially when the drones are on the sky, moving on the high end, the possibility of getting disconnection is high, right? So for that reason, we are using dew drone. Next. So drone cache is very important, as I mentioned, for reliable connectivities in the system. Next. So this is a picture of dew drone. Dew means here, when the drone is holding the data, it's like a dewdrop. It becomes bigger, bigger, and bigger. As long as second drone data is not get connected, means disconnection to connection, it will hold the data. Disconnection to connection, it will hold the data as if there is no disconnection. So this is a basic philosophy of dew drone. Next. We also worked for disaster management. Next. 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 Also, these drones are used for blood bank delivery, very popular, that especially during the accident, we need the blood, right? Real time. So drones can understand who is a blood donor, what is a drone delivery. Yeah, there are the very interesting blood delivery system. Lot of research paper is available. Even some of the countries, they're using these drones for blood delivery system with all precautions. Next. Next. So the third part, we are introducing the technology called federated learning. Next. Federated learning provides three important things called scalability, privacy, and performance. Scalability, privacy, and performance. These are the three working principles of federated learning. Next. You can see that we have multiple mobile phones. They can capture the data. This federated learning can capture the data from multiple mobile devices. It can be mobile phone. It can be your drone. That can capture the data from various corners, various geographical areas. But when the data will be combined together, it is going to the top, to the cloud. We are doing aggregation. But then at the time, only the patterns will go, but not the data. I mean, not the user data, not the user identity. So that is the basic principle of hiding the user's identity using privacy preserving machine learning, and federated learning provides that. Next. This picture shows that, you can see multiple right hand side picture shows that multiple devices, mobile devices are there. It can be drones also. Using this deep learning neural network, we are getting a pattern. Pattern means what is the pattern of data is available in that zone. Device 1, device 2, device N. But when these patterns are going as a weightage W1, W2, W3, they're combined on the top in the aggregation level, global level. But no identity has been disclosed. That is the beauty of federated learning. And Google started in year of 2016 called privacy preserving machine learning. Okay, next. So this is just showing the pattern, how this data actually moving using this federated learning from thousands of users. And we are getting the data from 1,000 users. Left-hand side, you can see this orange patch. We are collecting the data as a training purpose. And we are getting the data to the centralized server with the opposite direction arrow. And the engineer is doing this machine learning technique to aggregate the data, to generate the model, to generate the pattern. And after that, this red pattern, the common pattern is delivered to the maybe 10 million devices. Clear? So we are getting from 1,000 data, we are generating the model from 1,000 user, we are generating a pattern, but we are not disclosing the identity of the user. That is the main motto that is providing this privacy in the whole system. Next. So same thing, we have shown it using the drone. All the drones are providing this weightage W1, W2, W3. Ultimately, the global aggregation, you can see the summation sign. It is doing the aggregation and the global model is generated. After the global modeling is generated, WG is the global model. W1, W2, W3, Wn is a local pattern. WG is the global pattern. So local pattern to global pattern is generated. And ultimately, we are getting an excellent solution, privacy preserving solutions at the end. Okay, next. So these are the various types of attacks. I'm not going in detail. There are also, that if someone is there, want to give the poisoning of data, means by forcefully they want to, they give the poisoning of data. So it's called data poisoning to affect the training of the whole system. So it's called federated learning attack. But they are considered as an outlier. So there are a lot of techniques are there to stop or to mitigate the attack. Next. Next. So again, this is showing that how this aggregation is going on from this mobile data. So we are having a privacy interface on it. Next. Next. So these are types of attacks. It's part of cybersecurity attacks. So I'm not going in details, but this is all a huge area. Maybe it will take another 1 hour to discuss all this poisoning, how the data poisoning is happening. But yes, a lot of solutions are coming up based on this advanced federated learning technique called quantum federated learning. Next. So all our drones are actually always under the attack. So everyone is attacking these drones to get the data, to fetch the data out of it. So our aim is to protect them from the attacks. Next. 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 So these are the various techniques. I'm not going in details. There are various kinds of techniques are available to protect our data from various kinds of attacks. Yes, next. So this is the aggregation where we are aggregating from 1 to n, 1 to k equals to 1 to capital K, and where all the weightages are summed like this. So sampling to centralized control. So these are the machine learning techniques which is used nowadays in the drones for operations. Yes, next. Next. Also, drone can do the crowd sensing using federated learning. Means using the crowd data, we can tell you the better Google map. There's a application is going on nowadays in Google Map. Yeah, using this mobile crowd sensing. Next. There's a very interesting research paper called Dark Sky. Okay, we are actually a lot of attack is happening on the sky. We call it dark sky. Next. Hide and seek. There is another research. These are all the research papers by other scientists for last 2-3 years. Next. Next. Now, to mitigate this attack, people are using this quantum federated learning. Quantum computing is coming into the picture. Next. To mitigate this kind of attack, and these are the various technologies are there: quantum or quantum classical techniques, or mixed or pure quantum technologies are used. Yes, next. Next. So yes, quantum key distribution. One drone to other drone, data can be distributed using this quantum key, quantum repeater, and quantum supremacy. Repeater means which can regenerate, reshape, and retain the data. So quantum computing is coming to the picture for this quantum communication or quantum key distribution. I'm also one of the editor of this journal called IT Quantum Communication. Those who are interested, they can go through it. We have published so many papers in that journal, especially on quantum key distribution. Is IIT UK. Next. 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 Just go to before slide. Yeah. So before slide, before, not after. So this is the picture shows when multiple drones, they are doing this key distribution using the quantum computing. So, but the computation can be done in a fraction of a second because quantum computers are very much powerful in nature. Okay. So the connectivity and real-time operation is only possible with the help of the quantum computers. Okay. Okay. Next. 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 Yeah. Now we are at the last slide. So what you can observe so far, drone intelligence is the very important for future for sustainable smart city development. Federated learning, or what is also known as distributed machine learning, provides privacy preserving drones to protect the drones. Last, but the most important, quantum federated learnings are used to provide for ultra-fast global aggregation and to provide the security to prevention of attacks and everything. Thank you. So I've finished. Next slide. Yeah. So we have published one book. It is in the press called Internet of Drone Things. Next. Thank you. Over to the organizer. I have finished my discussion.
Thank you so much, sir. It is wonderful presentation. Any questions from anyone sides, participant sides? Any questions? Okay. So
I
thank
think
you.
we'll yeah,
Yes,
thank
sir.
you. Is it little bit okay? Means to you is understandable, madam?
Yes, sir.
Yeah. Okay.
It is wonderful presentation, sir. You have explained multiple factors of the drones in a field of IoT and federals. So it is wonderful presentation, sir.
Thank you.
So thank you so much, sir, for a wonderful keynote session. We are grateful for the time and effort you shared with us. I believe that, sir, your experience and depth of your knowledge in a federated learning for Internet of Drone Things will be benefited to our today's conference authors and participants. I personally appreciate your valuable insight for this your drone track. We're looking forward to you for your participation in our future events. Thank you once again, sir, for your contribution in International Conference on Advanced Communication and Intelligence System, ICACIT 2023.
Thank you. And it is also, in line of your theme, right?
Yes,
Theme of the
sir.
conference. Yes.
Yeah.
Thank you.
Thank you.
Thank you.
Thank you, sir.
Thank you very much. Thank you.
So next we are just going to start our technical session 4. So for the technical session 4, we have our session chair. We have our first session chair, Dr. Anirudh Dey. He is working as an assistant professor in a Department of Information Technology at Maulana Abdul Kalam Azad University of Technology, West Bengal. His sir did his BTech degree from the Computer Science and Engineering and MTech and PhD from the Javedpur University in 2000. PhD completed in 2018. During the PhD, he got project fellowship from the UGC and also from the state university, state government fellowship, senior research fellowships are got from the computer science and engineering department. Sir is having experience of 5 years and 6 months in a teaching, and Sir is actually successfully executed many funded projects by the Institute of Engineering India, Kolkata, and review many several SCS Coopers Index journal papers. Sir is having a more than 6 research papers in reputed referred journal and more than 14 papers in international conferences. Sir, interest or area of interest is a phase recognition and detection, facial recognition and satellite image processing. Yes.
Number 2.
Am I audible, sir?
Yes, yes, this is audible. Thank you for introduce me, and please go on the session, carry on the
Yes.
session.
Yeah, one more keynote session we have, sir. Nimati Masla ma'am, sir. So, ma'am, are you there?
कितना आएगा नंबर एक्टिविटी है ना यहाँ कितना होगा परसेंट dt होगा ना तो गलती लिखा होगा
Yes, Garima, I
Okay,
am
ma'am.
here.
Yeah, ma'am. Yeah. So, just for a brief about the profile of the ma'am. Ma'am is currently working as an assistant professor in CSE department at JSS Academy, Noida, and she did a PhD from the Banasthali University. She is invited as a distinguished speaker in a gas optimization of Ethereum smart contract held at the pre-conference FDPO Technology Advancement in the Research Development 23rd to 27th August 2021 MIT University. And ma'am is invited as a resource person for the machine learning, data science, and deep learning with Python during the AICT sponsored online faculty development program. And ma'am is also a moderator for a webinar on water informatics, introduction and case studies. And with this introduction, I just invite my both of the session chairs in our today's conference. So with your permission, I just start the technical presentation one by one.
Okay. Thank
Please,
you.
please
Thank
start.
you, Garima. We can start.
Okay, ma'am. Okay. Aurithru sir?
Yes, ma'am.
Please start. Please start.
Aurithru sir, first to call the paper ID name and then first confirm the author must be present
Yes, ma'am.
here. Then we will start the presentation.
Okay, ma'am. The first paper ID is 144. The author is present. Paper ID 1444.
Yes, I am present. I am Sagnik Jana. Today I am going to give a presentation about my paper, which is on the topic of a blockchain based approach to improve data integrity in federated cloud environment. First of all, let me discuss what is cloud federation. So in a cloud federation, multiple cloud service providers come together to provide integrated services. It has multiple benefits like performance guarantees. In a cloud federation, the performance is shared among multiple cloud service providers, so it enables dynamic workload distribution. Second is it provides convenience to customers, like customers can choose from range of available services the appropriate service which is best suited for him. In spite of its advantages, the cloud federation has its limitations. There are mainly two limitations. The first is to ensure trust among different participating cloud members, and the second is to ensure data integrity within the federated cloud environment. There are other limitations like data transmission and communication hurdles and security breaches, etc. Blockchain is essentially a chain of blocks. Every block in the blockchain contains the cryptographic hash of the previous block. So if anything in the block changes, it changes the current block hash, and it subsequently changes the hash of the all subsequent blocks. And it is very difficult to carry out such large scale tampering. So blockchain is immutable by design. So the aim of the proposed model is to use blockchain's immutability to mitigate the limitations of the federated cloud environments. The main two objectives are to ensure trust among different cloud service providers and to ensure data integrity in the federated cloud environment. So to achieve these objectives, I have proposed a two-layer blockchain-based mechanism. So the first layer employs a permission-based blockchain to store all the logs generated within the cloud computing environment, and the second layer focuses on ensuring data integrity to individual data items. Next I will discuss these two layers in more details. So layer 1 utilizes a permission-based blockchain for operation tracking. First, the blockchain is initialized with predefined set of cloud service providers as participants or nodes, and each CSP generates a unique cryptographic key pair for digital signature and encryption. When a transaction occurs within the cloud computing environment, the initiating party creates a transaction record with relevant details. The initiating party digitally signs the transaction using private key. The signed transaction is broadcasted to all CSPs within the network. Each CSP node validates the authenticity of the transaction using sender's public key. If the signature is valid and the initiating party is authorized to perform the operation, the transaction is considered valid. The consensus mechanism is based on proof of work. CSP nodes that are eligible to participate in current consensus round are determined based on the amount of cloud resources they hold. Validators take turn proposing a new block containing a batch of validated transactions. Other validators verify the proposed block's transactions and ensure that they adhere to the rules of the blockchain. Consensus is reached when a majority of the validators agree on validity of the proposed block. Once consensus is achieved, the validated block is added to the blockchain. The block contains a cryptographic hash of the previous block, ensuring the blockchain's integrity. So this is all about layer 1. Now I will discuss layer 2. So layer 2 focuses on ensuring data integrity to individual data items. It is divided into two stages. First is preparation stage and second is validation stage. In preparation stage, each data item is divided into smaller parts called shards. The number of shards can be predetermined. Next, the shards are distributed across various locations within the federated cloud setup. And multiple copies of the same data shard are stored in different geographically distributed locations to ensure availability and fault tolerance. Next, a Merkle tree is constructed for each data item, where the generated shards are the leaf of the Merkle tree, and then the Merkle tree is stored within the cloud environment, and multiple copies of the same Merkle tree is made. And the root of the Merkle tree is stored within the blockchain to ensure immutability of the data item. So this is all about preparation stage. Now I will discuss the validation stage. The validation stage focuses on verifying data integrity of individual data items. Here first the root hash of the Merkle tree of the target data item is retrieved from the blockchain. Next we request the corresponding data shards from different cloud service providers, and use hash function to create hash value of the corresponding shards, and from these hash values we reconstruct the Merkle tree and recompute the hash as recompute the root hash. If the computed root is same as the stored root in the blockchain, then data integrity is definitely intact. But if computed root differs from the stored root in the blockchain, then data integrity has been compromised. So the system regularly monitors the integrity of the data items by periodically verifying their Merkle trees against blockchain stored root hashes. So this is all about validation stage. Next I shall discuss the strength of the proposed model. So the following are the strength of the proposed framework. So first is enhanced data integrity. So the combination of a permissioned blockchain and a Merkle tree based approach provides a robust two-layer mechanism for ensuring data integrity. This approach offers a stronger guarantee of data integrity compared to relying solely on one method. The blockchain records all the operations while the Merkle tree verifies the integrity of individual data items, making it harder for malicious attackers to tamper with the data. The combination of permission-based blockchain and a Merkle tree-based approach not only ensures data integrity but also ensures the overall security of the system. With the immutability of the blockchain records and data verification capabilities of the Merkle tree, the framework provides a robust defense against unauthorized access and tampering. The use of permissioned blockchain provides transparency into the operations and transactions within the federated cloud environment. All participants have visibility into the blockchain records,